Looking at section 2.4, part 3, we're going to talk about what's called the remainder theorem. If you think about a remainder, as we've been doing those synthetic divisions or even the regular long divisions, when you have a remainder, it's what's left over. Well, now there's going to tell us some specific information about the remainder, which is what we're going to look at today, or as part of today. So it says, if the polynomial f of x is divided by x minus c, then the remainder is f of x. Well, that doesn't make sense, does it? If the polynomial f of x is divided by x minus c, then the remainder is f of x. Well, let's rephrase that. If the polynomial, so we take some sort of crazy big polynomial and we divide it. If the remainder, right, whatever the remainder is a value of the function at x. So for example, if this x minus c read an x minus 2, then we would look to figure out what is the value of the function at 2, or we would do that synthetic division where we would have put a 2 on the outside, done some sort of crazy numbers division, and then what's going to happen is we're going to look at what's our remainder. I'm just going to use a little r to represent the remainder. So once we did that division, whatever is left over, that remainder is going to be the solution to the function evaluated at 2. So that means f of 2 is equal to r. The value of the function at 2, x value 2, is whatever that number is, r. It actually gives us an ordered pair on our graph. So as we're going through graphing our polynomial functions, using our synthetic division, if we don't end up with an answer of 0, it's just going to give us a point on our graph. If we end up with an answer that's 0, that means that that is a solution or an intercept. It crosses that x-axis. So let's take a look. It says using the remainder theorem to evaluate a polynomial function. So given that f of x is equal to 3x to the third plus 4x squared minus 5x plus 3, it says to use the remainder theorem to find f of negative 4. So we're going to find the value of the function at negative 4 by using that synthetic division, because what an f of negative 4 means is that you would have had an x plus 4, which is where we use that synthetic division with that minus 4 after that negative sign, what we're dividing by. So if we were to take our function, we have our 3x to the third, our 4x to the second, our minus 5x, and our positive 3. That's where our numbers 3, positive 4, minus 5, and plus 3 come in. So we'll go about doing our synthetic division. We take that first number, we drop it down. 3 multiplies with negative 4 to give us a negative 12. When I take a positive 4 with a negative 12, that leaves us with a negative 8. Negative 8 now multiplies with negative 4 to give us a positive 32. 32 with a negative 5 is going to leave us with 27. 27 multiplied by a negative 4 would give us a negative 108. A positive 3 with a negative 108 would leave us with a negative 105. And this is our remainder. That last piece is what we're left with. So the remainder is a negative 105. So is the value of the function f of negative 4. That means f evaluated at negative 4 is going to equal a negative 105. If the remainder is 0, that means it is a solution of the polynomial, which means it is an x-intercept. If it's not 0, this means I have that ordered pair. When x was negative 4, my y value is a negative 105. That's what the remainder theorem tells us. Whatever the remainder is the value of the function at that number you divided by. Let's take a look at another theorem. It says the factor theorem. It says let f of x be a polynomial. It says if f of x is equal to 0, so the value of the function is equal to 0, then x minus c is a factor of f of x. That means that it divides in evenly, right? There's no remainder. It's a factor of it. Part B says if x minus c is a factor of f of x, then f of c is equal to 0. That means it's a solution or an intercept. If you end up with f of c is equal to 0, that's where it's crossing that x-axis. So an example says to solve the equation 15x to the third plus 14x squared minus 3x minus 2 is equal to 0, given that negative 1 is a 0. So negative 1 is a solution of that function. So what we're going to end up doing is we're going to use our synthetic division to divide using negative 1 as our divisor. Don't mind the bell. It's the end of the school day here on Wednesday. All right, so it says using the factor theorem, it says we are given that -1 is a 0 if f of x is equal to 15x to the third plus 14x squared minus 3x minus 2. That means the value of the function at -1 is equal to 0. So because f of -1 equals 0, the factor theorem tells us that x plus 1, because remember we're always looking at that x minus c value. So if we have x minus a -1, that means we're looking at that factor x plus 1. That's where this comes in. That means that x plus 1 is a factor of our function f of x. It says we'll use synthetic division to divide f of x by that x plus 1. So we put that -1 on the outside, and we'll do our synthetic division. That means we're going to start by dropping down the 15. 15 times -1 is a -15. 14 with a -15 leaves us with a -1. -1 times -1 is a +1. So -3 with a +1 is going to leave us with -2. -2 multiplies with -1 to give us a +2, and we end up with that remainder of 0, which we expect to have because -1 is a solution. That means it goes in evenly. It has to have that 0 remainder. So now it says this means that if we took our original polynomial function, we divided by x plus 1, what does that leave us? Well, if I had a third power, x to the third power, when I divided by an x to the first power, that means that this 15 is going to be 15x to the 1 less than 3 is 2. This is going to give us a minus x to the first power and a minus 2. That is what is left over once we did that division. So that gives us a 15x to the second minus x minus 2. So what does that mean in terms of our function? Well, if we divided by an x plus 1, that means that this piece got multiplied by an x plus 1 to give us that original function, right? The opposite of doing a division is doing a multiplication. So we're going to rewrite this as x plus 1 multiplies with 15x to the second minus x minus 2. And now we have a quadratic that we are going to simplify down. So looking at that, we can factor this down. Let's see. 15, a 1 times 15, or a 3 times 5. 2, the only way to make 2 is a 1 times 2, so we want to find what is our inside-outside terms that's going to give us that trinomial. We have to subtract to make 1. So that means I would take a 3x has to multiply by 2, a 1x has to multiply, sorry, not a 1x, a 5x. A 5x has to multiply with the 1. 3x times 2 is a 6x, 5x times 1 is a 5x. So we're taking a 3x multiplies by 2, we're taking a 5x and multiplying by 1. Now in terms of my signs, this needs to be a negative x, which means that the 6 has to be negative where the 5 had to be positive. The 6 to be negative, that minus has to go in front of the 2. And this is going to be an addition, and we drop down our x plus 1. Now we have 3 factors, and we set each factor equal to 0. So x plus 1 equals 0, which means that x is equal to our -1. We already knew that solution. They gave it to us. Our 3x plus 1, we set that equal to 0. That means 3x is equal to -1, which means we have a -1/3. And we set our last piece equal to 0. 5x minus 2 equals 0. That means 5x is equal to 2. Dividing by 5 leaves us with a 2/5. And now we just found the 3 solutions to our polynomial function. Remember, a solution is where the graph crosses that x-axis.